Hi, math people. So I wanted to talk about multiplication today, not just in the general sense, but a nifty little, I guess nifty is in my vocabulary in the regular way now, a nifty little trick for a certain group of numbers. So in order for me to get to that group of numbers, there are two steps I'm going to take before I get there. Let's observe 20 times 20. Okay, so 20 times 20, that's maybe something we can solve in our head, right? So a way we can think about that is, well, if I have 10 20s, I have 200, right? It's just an additional 0 at the end. Well, that takes care of 10 of them. I have double that amount. So rather than 200, I have double 200, which is 400. Okay, now I want to take this one step further. What if I gave you 21 times 20? Okay, so if we think about this one, I just have one more 20, right? Here I had 20 20s, here I have 21 20s. So if the last one was 400, I just have another 20, so this one's 420. Okay, so now for the very last one, I want to think about 21 times 19. Now, if I gave you 21 times 19, it's very likely that you would think that you can't do it in your head. Sure, you can carry the 9 and say, well, 2, or 1 times 9 is, well, that's 9, 2 times 9, that's 18, and then say, okay, well, 1 times 1 is 1, and 1 times 2 is 2, so that's 210, and you can add that up, of course. I'm not saying you can't do that, but I want to be able to do it in kind of a quicker way. In this situation, I had 21 20s, and I had 420. What I've done here is I've taken that away. I've taken away one of my 21s this time around. Think about it that way. So here I had 20 21s. Now I only have 19 21s. So I'm taking away a 21. So if I was initially at 421, or sorry, 420, and I'm taking away a 21, well, that's going to bring me down to 399. So if you notice what I've done, I've taken something as simple as 20 times 20, and I kind of used it to bridge to this kind of logical way of thinking about 21 times 19, a number, or I guess a pair of numbers that isn't something that you would necessarily want to do in your head, but check this part out, the even cooler step to this. So if we take a look at 20 times 20, that was 400. If we take a look at 21 times 19, that was just one off. That was just 399. And this is actually true for any single number that's multiplied by itself, this relationship. So here, 20 times 20, so that's like x times x, right? It's the same number times the same number. With 21 times 19, you notice I went one up from 20 with that 21, and that 19 went one down. And that relationship between the two numbers will always be one off. So what do I mean by that? Test it out on your own. So 10 times 10, think about that. If I were to move one of those 10s up to 11, well, first off, 10 times 10 is obviously 100, right? So I can write that down here. So 10 times 10, we know that that's obviously 100. If I were to move one of these 10s up to, say, 11, and one of these 10s down, say, to 9, using this kind of idea that I borrowed from, I'm telling you that they will be one off. Kind of the second number will be one lower, and surely enough, 11 times 9 is definitely 99. You can play around with this idea all you like. So I know that 25 times 25 is, I know that it's 625. I certainly do not know what 26 times 24 is, but I feel confident enough in myself to kind of follow out this idea to get that this is actually 624. Probably. No, it definitely is. This uses the idea of difference of two squares. So if you've ever taken an Algebra 2 class where you have, say, x plus 1 times x minus 1, you can multiply that across, kind of use like a box method approach, or I guess some people still FOIL nowadays. You'll end up getting x squared minus 1. So this idea, kind of a cool one, can come sort of into play off and on through mathematics. That is all I have for you. This is a short one on multiplication. I'll see you guys around. Please do continue to math on.